Hi, my name is Alex, and what I got for you today is a small Soviet-era portable radio. It has long wave and middle wave, and it is in a neat leather case made in USSR, of course. Your headset jack and your band switch. Being out of the case, it looks like this. SELGA from the Riga radio factory. This RRR, triple R sign tells us. And it has volume knob and tuning knob, and I did insert some fresh batteries over there. It's a 9-volt radio with a handy adapter, so you can use your 2A batteries, 6 pieces, to prolong its life. Here you see the model 405 made in USSR. I think this is end of 70s till, I don't know. I will definitely check on the date if we have any date here. Oh, so there's some stamp there. Let's see if we can read that. 1981. Is that right? Yeah, that's maybe it. It kind of works, but we have here in Czech Republic, we have no stations in middle wave band, so maybe we could hear something from Poland. It kind of works. Well, it produces noises. Of course, this is a very noisy environment because all the lights, everything is just a noise generators for this radio. I think it won't need capacitor change. I definitely won't be throwing capacitors at it. It won't help. Hi Shango. Yes, I know your thoughts about it, about throwing capacitors on the radio. Yeah, I'm totally agree with you. This is how it looks inside. Yeah, it disassembles quite nicely. The Riga factory was known as a producer of rather good stuff, so it's a superheterodyne with like 1, 2, 3 stage amplifier and low frequency amplifier here. You have your volume control here, and this 1 microfarad is the most common failure point in this radio. So if this capacitor gets bad and radio just produces almost no sound, but this is not our case. I think this is the volume control, so the cap is here. I think it has been changed. It has been changed. 5 microfarads, 15 volts, test lights from Czech Republic. I think, yeah, it has been changed. Someone has already been here because one of the screw has been broken and he is just sticking out here. And I see the broken trimmer pot. This is a low frequency oscillator trimmer, so it has like high frequency band, low frequency band. This is its switch, and this is the trimmer, low frequency trimmer. It's high frequency trimmer, it's untacked. This is high frequency coil, low frequency coil. Well, looks like this is 456 kilohertz intermediate frequency. We will check that because it was a standard frequency as for Soviet radios, and yeah, we will just check just to make sure. I think we will find it just before the detector, or we will try the collector of this T4 transistor. T4 is here, so it is yeah, it's this one. Collector is in the middle. Everything is rather simple. So let's take an oscilloscope and do some measurements. Well, here we are, and we have a nice waveform here. Let's take a look at the frequency. Well, I couldn't do it one-handed, sorry. Nah, it stays. Let's measure time and frequency. 355. Should definitely do a single swipe. So wow, 454. So this is a 455 receiver, not 465. You should definitely write it down. Yeah, this is a 455 first and only IF. That's nice. That's nice to know. We should do our math taking that in mind. Well, I have just made simple calculations. I just added the intermediate frequency to the desired frequency bands, and we will check now if the oscillator is running correctly. We will be here on the collector of the T1 here, and let's check if we will see the frequencies. The T1 is over here, and yeah, this seems like it this is the T1 and the collector is in the middle. So here it is. Yeah, sure, I would like to have 3 hands by now. Okay. So now I have my oscillator attached with a clip hook, and we are seeing now on the oscilloscope. Let's measure the frequency. 101 megahertz, and let's check. Yeah, this is frequency is changing, but the amplitude is changing also. So at the high end we see 2 and 2 megahertz. It's a bit higher than it should be. At the low end we are seeing, yeah, the amplitude is growing. I don't know why. At low end we see 990, 980. So 980. So the low end is there, almost there. The high end is not there. So let's check the other band. This is the other band. We should lower our frequency. So this is the lower side of the other band, 596, and we should have 605. So it's okay. I'm just turning the tuning knob from one position to another, and it shows us 898. Yes, about 890, 863. So the high end is high. Also here the high end is high, a little bit higher. So let's try to align the oscillator. Let's try to align the oscillator, and we start from the high frequency band from here. So a rule of thumb is the higher end is being tuned by rotating the trimmer, by changing the capacitance, the low end by changing the inductance. It's not that simple, but yeah, we'll try to do our best to So 980. Yes, the low end is pretty much there, 997. We may go a bit lower, 987, so 980. I'm changing the slug. 9. Well, it's hard to. 987, yes, 990, 985. Wow, it's jumping. It's a bit jumping. It's a bit jumpy. For more precision, we gonna. So 970 to 90. Yes, this is right on top. This is right. So let's go to our higher end, to the high frequency side, and here we have 2.21. We should have 2060. 2060. So trim a little bit. The other side, 207, 205. That's more like it. Let's check the other end if it stays. Yes, 206. Stays dead on the figure, and low end 980, 970, 980. That's correct. So let's align the other oscillator, the other band. So we should see here frequency not found. Basically, we will change the sweep time. Here we have we should have 605. 605. This is low frequency, and so we should rotate the slug. 605. Well, it's pretty much it. 601, 608. That's it. And the high frequency side, we should have 863 there. Yeah, we have a broken trimmer here, so maybe it won't be so simple. Maybe we should change the trimmer. We should see 863. 86. Yeah, it's jumping, but it's good. I think we are good now with the oscillator. Now let's check the reception performance, and just to make sure we have everything in range. We have here our waveform generator with amplitude modulation capabilities. So we would just switch on the amplitude modulation with modulation frequency 100 Hz. It's too low. 100. No, it's not that digit. There's this one, like 400 Hz. The modulation level 100%. Let's change to, let's say, 50%. Depth. Enter. Let's check our frequency. Yes, it is okay. It is okay. So let's change our main frequency to 1605. Let's do 1600 kilohertz. So 1.6 megahertz, and amplitude, let's say 0 dBm. It's definitely picking up something. Like let's turn the amplitude down to let's move the digits so it will be attenuating. Yes, minus 20 dBm. So it will pick up our it's picking up. It's picking up, it's definitely picking it up. I'm changing the amplitude, so I don't know, the coupling is very loose. It's like lying wire on the antenna, so I don't know how much of a signal the antenna is getting there. Let's try and pick the antenna. For this we are on higher band, and we should turn the trimmer on this band. We should turn C1. This C1 is over here, so we should just turn it for the loudest. Well, wait, we should do it now. This is not correct. We should do it in the middle of the band, about 30 or 20% into the band at least. So we won't mess with the antenna here on the higher side. So let's check the low side. We should put 525, frequency 525 kilohertz. So it will be frequency. I'll direct enter 525 kilohertz. So let's pick up the 525. So wow, we are receiving something neat. Well, here it is. Here we hear our 525. And the amplitude is minus 20 dB. So nice. Yes, and let's check the other band if we are receiving correctly. No, we should. We wanted to tune those antenna coils. So the resonance coils. So the middle of the band would be about, it picks up the phone. Yeah, it picks up the phone definitely. The middle of the band should be 1 megahertz. Let's input 1 megahertz here and try enter number and 1 megahertz. So we are doing 1 megahertz. Let's tune in. So let's, the amplitude is the minimum possible. So even further, and let's tweak for maximum. You can definitely hear the difference here. It's okay, let's move to the low band. Let's move to the low band. We'll start from the higher end, so 408 kilohertz, and let's check if we are able to hear it. Yeah, we are. We definitely hearing our reception, and and the highest, this is the higher. let's put 150 frequency, let's put 150 kilohertz. Yes, we are here. So the middle of the band would be about let's see, about 300. Let's put 300 here. 300 kilohertz, and pick this thing, tune this thing up. Yes, it is. So that's it. That's the end of the oscillator alignment, and we have done the antenna alignment. Just that simple, with no. Yeah, it should be done a voltmeter connected to instead of the speaker. So we should like really see the difference between the previous state and this and your changes. But well, it's just like this. It's not a precision radio, so it would do it. Now let's align the IF filter coils. For doing that, we just set the intermediate frequency here with amplitude modulation with that tone, and we see if it will pick up this tone, this modulation for 55 kilohertz. For 55 kilohertz, let's check our modulation frequency 400 and modulation depth 100. Let's make it at least 50%. Yes, and amplitude the lowest we can do. So let's find the quiet. Oh yeah, I think it would do it, and try to couple with that wire, some loose coupling, or I don't know. Let's make our signal stronger. Plus 18 dB, and we barely, plus 23 dB, and we barely hearing it. I think that would do it. So let's tweak the first stage. Coupling is it's this one. Yeah, should be L9 L10 here. L9 L10. The second one L11 L12. So L9 L10. You can definitely hear the difference. Yep. And this one is here. We should tweak it for the lowest possible distortion. Yeah, where it is. I think we are here, or we may even use an oscilloscope. Yes, now I'm picking up the signal just just here, just before the audio amplifier. And am I right? Yes. And yeah, the signal is a bit dirty, but you can definitely see when I rotate this slug, you can definitely see like how it's become distorted from one side. Yes, this is to one side, I'm rotating, this is counterclockwise, and it became distorted from another side. And you can definitely hear the difference in sound. I don't know if you are, but I can hear it. So let's put it like this. Yeah, it's hard to. Why it's not synchronizing? Where do I have this trigger? Let's put a trigger somewhere on top, so we are be able to. Yeah, you definitely see the amplitude is changing and your signal form is changing. Well, I think it's a bit hard to catch it on video, but in person you can hear that distortion by your ear. It is coming from the speaker. So that's it. I think the radio is fine, and let's test the reception quality. I don't know if we have anything on the band right now. Let's see. And here we have our radio in its natural habitat, in nature, reasonably far from anything which could be a source of any interference. So let's see how it performs here. The smartphone also induces, yes, that's it. Smartphone also induces some interference. I don't even know what to do, how to film it without a smartphone, without any electronic device. This clicking comes only when I have smartphone nearby. This was one station in middle wave band.
Organizacji ksiądz Marcin Iżycki. Kasza, ryż, mąka, cukier, te wszystkie produkty, które uda się zebrać.
And one clear and loud station from Poland in long wave band.
Żywnościowa trafi do ubogich, bezdomnych seniorów czy osób z niepełnosprawnościami. Podczas poprzedniej akcji w grudniu 2022 roku udało się zebrać ponad 250 000 kilogramów żywności. Patronem medialnym akcji tak. Kwietnia, a rewanż odbędzie się tydzień później we Florencji. Losowanie odbyło się w Nyonie. Lech wyszedł z grupy z drugiego miejsca. W barażu o 1/8 finału wyeliminował wicemistrza Norwegii Bodø Glimt, a wczoraj przypieczętował awans do ćwierćfinału.
The sound is nice and clear, and I think it performs how it should. Although it's fourth class radio, so don't expect any miracles.
Z Bazylei lub Nicei. Wicemistrzów najbardziej... Costurile falimentului vor ajunge să golească tot buzunarele românilor. Trebuie doar să ne reamintim că falimentul anterior de pe de la City Insurance a adus tarife mult mai mari pentru poliție, la valori care au tot continuat să crească. Iar asta și Carpatica sunt alte nume cu aceeași rezonanță. Ilianorescu are toate detaliile.
Yes, this is another station on long wave.
A milioane de români. Decizia retragerii autorizației a fost luată
I do not recognize the language. I think it's Romanian.
din aplicarea unui proceduri de rezoluție, precizează ATP.
Let's scan the medium wave once more. Let's clicking.
A külső és a leállósávot az oltás miatt lezárták. Tűzeset miatt teljes útzár van a 4-es főtó Monori erdő belterületén a 41-es kilométer közelében. A forgalmat mellékutakra terelik.
Budapesti információkkal folytatjuk.
Budapest.
Jó napot kívánok! A fővárosban lezárták a 11. kerületben a repülőtéri utat a Tóérberek utca.
Here we have a Hungarian station.
Tátományi János út közelében a 179-es autóbusz terelve közlekedik.
A Budapest Segrét és a Budapest Segrét szólnak.
And two stations in long wave band. That's it. Czech Republic has turned off its transmitters in all shortwave bands, so we cannot hear any Czech stations anymore. That sums up my story about the radio, the Soviet radio SELGA 405. That's about wraps it all. Thank you for watching and bye bye.